I've had the Impossible Burger. I've never craved an Impossible Burger. There's so many great burgers you can get out there. Shake Shack, Five Guys, In and Out. Why would I go to get this Impossible Burger unless I was doing it like vegan stuff? Beyond Meat and these P1s, they're all processed, highly processed. They got a lot of fat, right? They're not good for you.
So the way that Beyond and Impossible and others have tried to make it taste good for people is they've added a lot of, saturated fats, which is a way to drive the mouthfeel and make it taste good. But then a lot of doctors, the American Heart Association came out and said that those fats are really bad for your heart and you shouldn't eat them. And also there's been a general kind of consumer sentiment shift. So a couple of years ago, these were the hottest products. It was like all the food ingredient companies were shifting to plant-based proteins and they were building plant-based protein business categories. And it was this big hot thing. And then they came out and they're like, wait a second, this isn't going as we thought. What happens is people try them out and they're like, yeah, that's a cool thing. I want to do good for the planet. But would I rather pay $5 for a do good for the planet burger that kind of doesn't taste that good? Or would I rather pay $3 for a burger that tastes really good?
When Beyond Meat and Impossible Foods came onto the scene, there was a lot of hype that these companies were going to completely replace all meat products. Unless you were vegan, they were okay, but they weren't a one-to-one replacement for normal meat. They didn't have that flavor. We need more innovation in the space. There's lots of cool things that different companies are doing to create better quality meats. One of the things they're doing is by using fat, creating better fats. So let's look at a bit of why the saturated fat issue came about for the early products and how subsequent products are going to be fixing that issue.
A lot of plant fats, they're kind of short chains and they're a little bit kinked. So they look like kind of like that when they stack up on each other. Once you make unsaturated fat into a saturated fat, it kind of takes those kinks out and straightens them. And then you have it so that they pack really well. And this is why those animal fats are solid, because those fats can pack very, very well. They're straight. Whereas the plant oils that are a little bit kinked like this, they can't really stack on each other. So they end up forming an oil because they're not interacting with each other in such a way. The issue with that is once you start straightening them out, you're making a saturated fat. That's essentially what ends up happening on the molecular level here. If we're trying to add any nutritional advantage to these, getting away from those saturated fats is awesome. There's a few things that we can do to actually make these fats. You can either construct them, take oils, don't even modify them at all, and then construct them into a building block that looks like a solid fat without actually having to modify those kink chains. So that's exactly what Jason is working on, is you just take the oils as is and you encapsulate them up, and then you get the nutritional advantages of having unsaturated oils.
Another issue that will come up is that we have to use a ton of coconut oil, which is currently what's used in a lot of these products, and it really doesn't perform as it should. And we're going to have to use so much of it that we'll have supply chain issues. So I want to look at what one of the companies is doing to fix this problem.
Let's assume that we just make all of our plant-based meat exactly the way that we do now. That means a lot of coconut oil. It also means a lot of these other ingredients here, but let's focus on coconut oil. For coconut oil in 2030 to meet 6% of plant-based meat demand, we would need about 0.61 million metric tons of coconut oil to fulfill that. What that ends up coming out to is about 16% of all of coconut oil that will be available in 2030, which is insane, right? We can't have 16% of coconut oil go to just 6% of meat products. There's a huge problem in that. There will be a supply chain bottleneck if we don't look at that a little bit more closely. That comes out to about 19% of all coconuts cultivated. That's where you see that 19% there. This might end up leading to really high costs of coconut oil, making it really, really difficult to get. But then on top of it, if you've ever worked with coconut oil, you know it's not the best animal fat replacer. If you end up putting that in a plant-based burger, how good is it really at mimicking those animal fats? There's going to be a lot of limitations as far as mimicking milk globules and other types of animal fats. So I think we can do a lot better from a technical perspective, and we can definitely do a lot better from a supply chain perspective and from a humanitarian perspective. Coconut oil, palm oil, these tropical oils, they're not very sustainable and they're not very humanely harvested. Jason is the Chief Product Officer at Shiru, an ingredient company that leverages machine learning, bioinformatics, and precision fermentation to identify and create functional, sustainable ingredients for the plant-based industry. Before joining Shiru, Jason worked at Ferrero. He actually lived in Belgium and was working on chocolates. I'm very jealous. And as well as Amorous. So he has a really great technical background. I'm very excited to hear about what Shiru has been up to.
When I think about fats, I kind of feel like it's the overlooked macronutrient. The deliciousness impact of fat, I think, has long been overlooked, and I think it's a really critical aspect for us to solve, the likability of the products that we're trying to deliver to really transform to sustainable performance. And so, that's really an intentional choice that I've made in my career to focus a lot on fats. We've had the great fortune at Shiru to use our platform to be able to exploit proteins to turn fats into delicious fats to transform the industry. So OleoPro is what we'll talk about today. It's a part of Shiru's business. We'll talk a little bit about Shiru and then talk about our OleoPro high performance fat solution. The performance of coconut oil, of palm oil, of traditional hard fats in confectionery is exceptional, right? And there was no alternative, in cocoa butter, and these are great. But now, as we think about animal fat replacement, is a whole different request from the product, right? It's no longer triglycerides, right? We're trying to make products that taste delicious and juicy and have fatty mouthfeel, and that's a real gap as we think about trying to put coconut oil into these systems today. And at 10, 20% of the product, it's a disproportionately high impact on taste and likability. And I think this is a critical aspect. In the world of plant-based meat, it's a whole different ask, right? We're talking about animal adipose tissue, not triglycerides. These are oils that are bound within tissue that when you heat them, they stay together even if they're molten, right? This is what adds to that deliciousness. So it's retained through the cooking process. As we chew, you get that mastication and that fatty release, that fatty mouthfeel, all those fat soluble flavors that are bound within there to really deliver the taste performance that we expect. Coconut, liquid oils, and hard fats today, we're having a challenge bringing those in, delivering that same taste performance. One very simple way to look at it is as you cook it and the oil gets released, simply you're losing a lot of that ability to deliver that flavor and that expectation. So at Shiru, the main focus is about leveraging insights, digital insights to predict protein functionality, to test and validate that functionality. So we use a computational approach to make this. In our dry lab function, and then the wet lab, we validate these insights. And so through that process, we have a couple platforms. One of them was around understanding how proteins react to temperature change. And through that, we developed an analytics platform to be able to look at things that bind water, but also things that can bind oil. And so what we found is now through a unique blend of non-GMO, commercially available plant isolates, we were able to manipulate those, to process those in a way that allows them to hold oil very tightly. Well, maybe very tightly isn't exactly it, just tightly enough, right? You want it to hold a little bit, be ready to release those. So that's really the key. That Flourish Insights, our computational and wet lab function identified this range of ingredients and a process by which we can hold liquid oils and turning them into OleoPro. There's an example of the product on the right. That's a 95+% liquid oil with around 5% plant protein, turning that liquid oil into a premium fat, fatty by touch, fatty by mouth, and working in the products. And so this is our high performance fat solution. Again, we're using a range of unsaturated liquid oils. And so you can also take the arguments around saturated fat and unsaturated fat as you want. But from a label standpoint, from a consumer acceptance, generally, we're going to move away from saturated fats and into unsaturated fats to get more nutritional, higher score and higher acceptability. And of course, moving to broad acre crops that produce oils away from tropical oils allows us to provide a much more sustainable and scalable raw material resource for building these fat solutions. We're really focused on delivering the performance that the partners and the customers need in order to make the change. And so juicy, fatty mouthfeel is the first, is the second, and is the third focus for us. So what have we done? We've done a lot in in ground type products, a lot of work in-house and with partners to look at just really one-to-one replacement. This is not an emulsified product. This is a one-to-one replacement in which you gain a direct swap for coconut oil typically. We've done this at scale. We've put this into products in a range of different mixing at 100 kilo scale, made finished product out of it. So it's working from a processability, really a key aspect to not just build something that works in the lab and you taste it, but that works in a scaled process. So we've run this a few times at multiple facilities and have very robust processability for this. And then from a labeling standpoint, it's really liquid oil and a blend of proteins. The liquid oil is quite flexible. We can turn olive oil into a spreadable or an olive oil fat. We can turn sunflower oil. And so all this, we fast tracked the patent. It should be have a readout in a month or two. And at that time, we'll be a little bit more open with what we can say about the competition of the but that's where we are. So now how does it perform? Again, these are some metrics. The first one is maybe not a hard one to get, but I thought it was easy. Okay, the oiling out is a process, mass loss, right? Some of the products we might try do hold oil, right? And the mass loss is lower. But then when you taste them, it's still holding oil and you're not getting that fatty mouthfeel. And so in some of our early iterations, I thought, wow, great. Mass loss reduced. This is going to be a great product. And you tasted it, it was dry, right? So it's the fine balance of holding that oil, but then getting the third-party sensory panel data we get below, which is an increase compared to that on that juiciness, which is I would say one of the most ephemeral and challenging aspects of these products is that juiciness. And so we're holding onto that oil tightly, but not too tightly, and it's allowing the product to really taste well, and as well as a bit from the side. So where are we in the process? We call this our anhydrous oleopro. So this is a product we're making again with a few percent of this plant proteins, and we're really actively partnering. We're scaling this product with contract manufacturing and an active commercialization in these mince type products.
I have like two parts of my role. One is my hardcore, like I do bioinformatics. I'm trying to take a big database of many plant components and try to choose the ones that can replace food ingredients. But I also do translation between people that do the experimentation, people that do hardcore machine learning stuff and artificial intelligence. So being the bridge between the two groups.
Thanks again for watching. We'll catch you.